Hi there, I'm Peter, Managing Director of GlasCurtain. Today we have episode 2 in our Curtain Wall Conversation series, where we talk to industry experts to explore new ideas of what's possible with glazed facades. In this episode, we're talking to Alex Worden. Originally from Calgary, Alex has lived in the States for over 22 years. Completing his master's in architecture at Virginia Tech, he would go on to specialize in parametric workflows, digital modeling, and fabrication techniques, working at several high-profile envelope contractor and engineering firms, as well as co-founding Boulder, Colorado-based StudioTJOA with his wife and business partner, Audrey. Since graduating in 2011, Alex has worked on numerous world-class projects, such as VIA W57th by Bjarke Ingles Group, the SoFi Stadium by HKS and Zahner, and the Lucas Museum of Narrative Art by Mad Architects, and of course closer to home, the 9th Avenue Parking Garage by 546-8796 Architects. We had a great time chatting with Alex about facade retrofit considerations, embodied carbon, supply chains, the challenges of flame spread testing, and much more. We hope you enjoy this wide-ranging conversation as much as we did.
The idea of like overcladding, the weight aspect, and how we're planning for future retrofits and things like that. So there's a Facade Tectonics 2020. I actually moderated the presentation that Daniel Kelso gave, who's a friend and former student of mine, who went to Enclose. I actually I told Enclose, like, hey, straight out of school, I was like, you guys need to hire him now because your competitors are going to hire him, and they did. He gave a presentation on a topic called designing for distance. And it was this idea, and the paper's available on the website. So on Facade Tectonics, if you type in Daniel Kelso, Kelso, or designing for distance, his proposal was designing curtain wall mullions today for future retrofit applications.
Yeah.
Right?
Yeah. And
he created this really interesting like clip system to like, so then how the North American style like split mullions are the sort of open web with the anti-buckling clip.
Yeah.
He designed an anti-buckling clip system that could be toggled on and off by way of just like rotational, a rotational tool, and then you could take a unit out, in situ, right? And then you could retrofit it and put it back in without having to deal with like the, typically you have to take a reciprocating saw and cut out the clips and then remove, and then you poke around to do retrofits. He was proposing something different. So I recommend anybody who's interested in that, take a look at that paper because it's a really good paper that he did. But the idea of designing for the future retrofitting is something that's hugely important to Audrey and I at TJOA. In fact, the paper that I wrote, my statement of interest to get me into grad school at Virginia Tech, I wrote on systematic demolition of buildings and the architectural knowledge that is required, and that architects need to be more knowledgeable of building construction methodologies in order to design for demolition. Now, demolition could easily be flipped to retrofitting and systematic or localized demolition for retrofits. This is where that knowledge, the knowledge that Audrey and I gained working at Enclose, working as contractors, being in the facade space for 11 plus years now, system design, facade architects, curtain wall specialists, parametric specialists, and things like that too. The fact is that like that's what we're trying to propose with this sort of ETFE cladding system that we've put in our patent application for and are actually moving forward with it. With sort of this thermal switch MetLife competition idea and making it more of a reality. So that's what we've found at the very least is, the weight aspect is huge. And one of the things that helps us in our product exploration and system exploration is the fact that this overclass system that we're developing actually is probably one of the lightest weight overclass systems that would be available. due to the nature of the framing and the fact that we are using an ETFE film.
Right.
So, when you can take the stress off of existing buildings and even the engineer, right? Taking the stress off the engineer.
Sure.
From trying to figure out the calculations of like, is this brick anchor going to hold up this panel system?
Right.
So anyway, yeah, just I think that
the weight is a big consideration too, and that's a consideration when we're talking about these other kind of retrofits, into whether it's replacing a curtain wall or it's over top of like you were talking about other just tall multifamily residential buildings where you just have a punched opening and you have facade. Like both situations, the weight is very important. And this is like there was who was it like Buckminster Fuller or something asked like Norman Foster once, is like, Norman, how heavy is your building?
Mm-hmm.
Or like how much does your building weigh? And there's actually a great YouTube video on that as well. But it's like it's so rarely a topic of conversation. Like how much does a building weigh? I know with more newer parametric techniques. I remember like recently Zaha Hadid had designed it was like the Mexico City airport or something that used like 30% less concrete or something like that, because they were trying to make it as light as possible to have as reduced as little carbon impact as possible. But I think that is I think as we get better and better at all of the operational sort of thermal performance things, next we have to look at the embodied impacts. I think that's something that is still, LEED looks at very closely, but Passive House unfortunately doesn't, for example, yet. But then it's going to be things like weight. I think, because weight, especially in the world of supply chain disruptions, because weight is also logistics.
Yeah.
Weight is not just, how much can our existing building hold if we're retrofitting it. Weight is also, moving materials across the planet and the environmental impact. And, you need that much more fuel to move these, materials across the planet. You need that much more, the vehicles need to be that much bigger and heavier and stronger to handle it too. So it's all the way down, all the way down the supply chain.
That's funny that you mentioned, like we're talking about the weight of material, and that's actually something that like the paper that Audrey and I are writing with co-authoring with Ki-Hong Koo, who's the head of the PhD department at Thomas Jefferson University, on these ETFE cladding systems. So Thomas Jefferson University just did a solar decathlon China project. It's called the Y House, and it's a entirely double skin residential project.
Yes.
And there's not much on it yet, but it will be. It's currently in second place. The judging will be in June, but it's a double skin ETFE outer sort of pillow system, which is quite amazing. We were their facade consultant and industry advisor during design, and then it actually got built. So
I think I saw you post that on LinkedIn or something like that.
Yeah.
So that was super cool.
Yeah. So anybody who's interested, type in Solar Decathlon China 2021 Y House or Thomas Jefferson University. You'll find it. But what we're talking about, we're using that project as a precedent and the MetLife project as a precedent, and then we're going to move into in the presentation in October that we're going to give. We're going to move into what we're doing with the sort of next gen product that we're developing, and for retrofits. But we actually did a whole calculation on embodied carbon, the difference between embodied carbon of glass versus ETFE. We had to go all the way down into not just weight, because how like companies will like to kind of play with the numbers. It's like meters cubed versus metric ton versus
Their unit of count are all over the map, right?
Right. So the EPDs, right, the environmental product declarations of these materials, especially ETFE, that one gets a little tricky, because a lot of these companies, like you can find like Texlon or Novafol, you can actually find the EPDs, but they're for meter squared of system assembly, not of ETFE alone, right? We ended up finding ETFE alone relative to a single sheet, but then we had to do this calculation. It's an easy calculation. Audrey was even saying, like, why are we even doing this calculation? Because it's like, one, it's a film of 250 microns thick, right? At a meter by 250 microns thick equals X carbon emissions, right? Or not carbon, but embodied carbon, right?
Tons
the GWP, that's the unit.
Okay. Yeah.
Multiply that by the thickness to get a meter is X number of sheets. So then we can finally get an apples to apples. And we realize very quickly, we're like, oh my God, the GWP on ETFE versus, in a meter cubed versus glass. And we saw the number and we were
like, is it through the roof?
Yeah, it was very high. It was orders of it was exponentially higher than
orders of magnitude.
Yeah. But
wow.
But here's the thing.
Yeah.
When you start actually going to apples of like, okay, what does this actually mean? When you look at, we ended up going into a term that we kind of coined for ourselves, but I'm sure it's being used, or there's probably another industry term for it, but operational thickness.
Okay.
What is the operational thickness required for glass?
Sure. 6 mil glass or 3 mil triple pane is 18 millimeters thick of glass in a standard unit.
Exactly. To get X, U value,
sure.
right? Center of glass,
R10 or whatever. Sure.
Same thing. Yeah. We did the same thing with ETFE to figure out operational thickness required to get X U value.
Yeah.
Right. Comparable to glass.
Yeah.
All of a sudden, the ETFE system plummeted on the GWP.
Sure.
Right. Now, instead of like, I think it was something like a glass double glazed unit with the U value that we wanted, standard 0.3 or something like that in imperial units. R3-ish, right? Yeah, exactly. Yeah. They were looking at something like 50 GWP or something like that. And then, and don't quote me on this because the numbers, we have the numbers, we'll present it at FTI 2022. Sure. But it was reduced by a quarter, but not by a quarter, by like, it was like 10 instead of 5. It was like so much lower, but that was because of the operational thickness and the weight aspect of it, right? But then when you look at the weight aspect of it, there are things with ETFE that you gotta kind of consider. One, there's the internal stresses on a single skin that's stretched and things like that. But the weight on the existing structure, right? So that's what when we saw that, we were like, we have something here. There's something in the MetLife, thermal switch proposal, right, where we were taking these sort of like C-channel frames and kind of putting them over the precast.
It's something we're going through right now as well, because we're about to, we were originally thinking that we were going to retest our new passive system to CAN-ULC and S130 and NFPA again. But it's now looking like we might be able to do, we'll still have to do the NFPA test, but we might be able to do just like an engineering assessment or like a smaller scale mock-up, because the difference between our existing curtain wall system and our new passive system, it's like 5% different.
Yeah.
Right. It's not, there are important differences, to be sure, but it's not like they're night and day different. Like we're testing some totally, clean sheet design. It's definitely an iteration of what we already have. So it's like kind of crazy, to have to go through this, big $100,000 plus test all over again, if there's, a more economical solution that provides the same assurance. Because at the end of the day, it's like exterior flame spread test. And it's like, if you aren't really changing anything outboard, and it's an exterior flame spread test, you're using the same aluminum snap caps, the same fiberglass clutcher plates, and you're making a few, small minor differences in the interior, the shape of the mullion a little bit, some of the gasket shapes, and that's kind of it. It's like, why go through the whole like rigmarole again when there's so much similarity? So we're in the process of doing that, and we should be actually finding out in the next few weeks, if not a few months, what we need to do to get that design listing updated with Intertech. And then we're hoping to actually do our NFPA fire test in April or May, probably. Don't quote me, don't hold me to that, but that's our current timeline. So this is very pertinent, very relevant. So by the time this conference happens, we will have had experience, and we will have had sort of like lived experience with designing and testing to non-uniform assemblies, because these tests are also designed for, at least in theory, at least originally, for uniform assemblies of, whatever combustible cladding materials, right?
Yeah.
Yeah.
That was always something that I found to be a little bit of a hurdle that was put on the manufacturers, was that it's an assembly test. So it's like, okay, so Cascadia or GlasCurtain or whomever has to test with glass infill, with metal panel infill, with, and then metal panel infill can be changed to anything else, UHPC or, ACM panel, et cetera, and it just bloats from there. And it's like, I mean, NFPA 285 is a destructive test, so you can't reuse anything. It's not like a cycling test where you go 50%, 100%, 150%, and then, but at least you've got the first 50 and 100 before you do the destruction test or the destruction cycle. Yeah. Even then, sometimes those performance mock-ups still survive just fine. So with you guys are using Intertech, are you guys doing that in the States? Or?
Yeah, the only facility left in North America. So once upon a time, we actually tested the CanULC S134 in Canada. So there was a facility outside of Ottawa that was sort of in our very, very early days, actually, before I joined in 2013. So that was in like 2010 or something like that. And unfortunately, we actually failed that test at the time because not from a design issue. And I don't actually share this very often, but like maybe I should, because it was actually just to do with installation. So there was actually just a small gap on top of the combustion chamber before the first horizontal mullion came, and the fire ripped in around the backside of the curtain wall and ate it from the inside, when the test is actually not supposed to test that at all. The test is supposed to be, from the outside. We didn't know, and the testing agency isn't there to babysit you. The testing agency isn't there to tell you, hey, GlasCurtain guys, maybe you should just crush that gap just like from an inch to like a millimeter, because from their mind they're like, this is just business, and they're also supposed to be impartial too. Like, I get it that they're not supposed to help you pass, because the point of the test is not to pass. The point of the test is to install it as if you were actually installing it, and then to determine if the product is safe or not safe for non-combustible building envelopes. Unfortunately, in situ, you would never have that gap. You would never have a non-fire stopped gap at like a slab edge. You'd always have like some kind of fire stopping. You'd always have like really a secure sort of space, and you really there shouldn't be a way for fire to easily get in behind a curtain wall in situ. But unfortunately, just the way we assembled it, we didn't know at the time. No one was there to tell us. So when we retested it in 2017, 2018, we closed that gap and we passed no problem. Right?
Yeah.
It was literally the only difference. Close the gap, pass the test. And so we are now hoping we don't have to make this same kind of like learning mistake or like learning lesson. There's no such thing as mistakes. There's only lessons with our NFPA test. But to your question about the States, so that facility outside of Ottawa closed maybe 6-7 years ago, and now the only facility on the continent that can do CanULC actually specifically, and then also do NFPA. Additionally, there are other facilities that do NFPA, but not other facilities that do CanULC, was with Intertech. And so we're going back to just outside San Antonio, Texas, to do that test with Intertech. That's sort of the facility for that. So
that's cool to know. I mean, I think but like when I left Calgary, I moved from Calgary to Dallas, right? So 15 years old, going to high school in Texas. I leave Calgary for, the big city, like I'm moving on up. And then I lived there for 10 years. And then I realized as we were leaving, I met my wife there. Audrey's from Texas, born and raised. But when we were leaving to go to grad school, I was like, oh my God, it was the exact same, it was not the same culture, but it's like Calgary, right? Cowtown, cattle, cowboys, and oil. Texas, Dallas, cattle, cowboys, and oil. Like,
yeah.
So, but then, you know, you get the Bible Belt sort of like, you know, aspect to it. That's really the biggest difference. But, you know, still like middle of the country's type environment. But I asked that just because I remember you saying that some of the testing that you were looking at with Intertech, I think was potentially in the DFW or the Plano facility, which is just outside, just north of Dallas. But it's really good to know that the CAN ULC can be done at the San Antonio or just outside San Antonio's facility. I didn't know that they had a San Antonio's facility.
Thank you very much, Alex, for taking the time today. And yeah, curtain wall conversations will be coming soon to a theater near you. And but yeah, we'll definitely send it out when we get that to share with your audience, as well as thank you for sharing that with our audience.
So there you have it, our second episode of Curtain Wall Conversations featuring Alex Worden. We hope you enjoyed our conversation as much as we did. Be sure to follow us on LinkedIn, Instagram, Twitter, and Facebook to stay up to date on new episodes of this new series. Also be sure to check out our Spotify account, where this episode and others are now available, with Apple Podcast coming soon. If you have any questions about our conversation today or fiberglass framed curtain walls in general, feel free to reach out to us on email at info@glasscurtain.ca with one S in glass. And you can also subscribe to our blog for all the latest updates, which we'll link to in the description below. Thanks very much. We'll see you next time.